Section 710 is on simplifying radicals, and in order to do that we need to be aware of what perfect squares are because these are going to be really helpful in simplifying. So go ahead and use either your green power sheet or your calculator to fill out this table. So this is what your table should look like, so go ahead and make sure that you have the right values here. And then these are the numbers we are going to be referencing when we try and simplify today are the values of the perfect squares. So everything from this table. So the property that we're going to be referencing today, it says the square root of A times the square root of B is the same thing as the square root of AB. So we're going to use this property to break apart a number to simplify it down. So we'll actually be working both in multiplication and division today. So why do we use this and how do I know which numbers to use? And we're going to use the perfect squares. Okay, so what is this going to look like? So I want to simplify the square root of 8. So what I want to do is find a perfect square that breaks down 8 evenly. So if I looked at my sheet, my list of numbers, the first one I saw was 1. Well, obviously 1 divides into 8 evenly, but I want to find a bigger value. So then I would look at 4. Is 8 divided by 4 a perfect integer? And that is true, which means I could break the square root of 8 into the square root of 4 times the square root of 2. So 4 times 2 gives me 8, and I know that this one is one of the ones off of my table from the top. So the square root of 4 simplifies to 2, and then the square root of 2 is a irrational number, so we're just going to leave that and simplify that into 2 times the square root of 2. So why is that simplified? Because what is underneath the radical sign 2 is now a smaller version than 8. So if I look over to number 2, the square root of 108, I want to find, again, one of those perfect squares that breaks down 108 evenly. So if I try to divide 108 by 4, that does not go in evenly. Then I would try 108 divided by 9, that does not go in evenly. 108 divided by 16, that does not go in evenly, and you should be using your calculator and trying these. 108 divided by 25 does not go in evenly, but 108 divided by 36 goes in evenly, and that goes in 3 times. So now again, this one is the one from the table. So the square root of 36 is 6, and the square root of 3 is irrational. So I simplify that into 6 times the square root of 3. Moving on to number 3, again, I'm looking at all of those perfect squares that we wrote down. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, etc. That breaks down 700 evenly. And what will break that down evenly is 100. And will that break it down 7 times? So 100 times 7 gives me 700. This is one of the ones from that list above, which simplifies to 10. And then the square root of 7 is irrational, so we leave it like that. Number 4, again, you're going to kind of guess and check numbers that divide into 245. So 1, 4, 9, 16, 25, 36, 49, 64. Divide into that until you can find one evenly, okay? And that should be 49. And 49 goes into 245, sorry, not 7 times, but 5 times. Okay, this is from the sheet above, so that simplifies to 7, and the square root of 5 stays because that is irrational. Moving on to 162, okay, go ahead, guess and check. Divide on your calculator, 162 divided by 4, 162 divided by 9, 162 divided by 16, etc. And find one that goes in there evenly. And you should find that the square root of 81 goes in there twice. So the square root of 89, again, is one of the ones from above, so that's 9, and then times the square root of 2. So there's your simplified answer. 125, looking for things to break that down. Hopefully that one was easy to find because 25 should go in there 3 times. Again, 25 is one of the values from above. So 5 times the square root of 3 because the square root of 25 is 5. If I keep going here, number 7, I would say that, oh, square root of 9 goes in there and then 6 times. 9 is off of my list, so that simplifies to 3. Then I have the square root of 6. Number 8. Okay, a lot of you might say, ooh, 12 times 4. okay, because 4 is one of the ones off of your sheet. However, 12 is still pretty big, and 12 has some bigger values that would go into there as well. So I'm going to look for something bigger than 4, and if you keep looking, then 16 breaks down 48 3 times. So again, you want the biggest number off of that list that breaks your number up evenly. The square root of 16 is 4, and then I have times the square root of 3. Number 9, 1,440. Well, that one hopefully should be kind of easy to see because 144 is on our sheet. So that would go in there 10 times. Again, you're looking for the biggest value to break that down evenly. The square root of 144 is 12, and then I have left the square root of 10. Okay, so again, the numbers we are looking at are all of these numbers in blue. So this is the list that you want to get really familiar with, and maybe even right at the top of your sheet so that you can keep checking these numbers and get really familiar with them. Okay, so now what happens if I put a variable in there? Okay, well, this is the square root, which means there's an imaginary 2 sitting right there. So what you're going to do is you're going to divide the inside number by the outside number. 2 divided by 2 is 1. So then that's going to simplify to a to the first power, or just a. Okay, number 11 has 2 pieces, so I'm going to break that up into the square root of 25 and the square root of a to the 5th. Well, the square root of 25, that is actually off of your sheet, so that's just 5. And then again, there's a little 2 sitting right here. So 5 divided by 2 is 2 with a remainder of 1, which means that a squared will come out and then 1 will still be left inside because your remainder of 1 stays inside the square root. Okay, so 5 divided by 2 is 2 with a remainder of 1. So your exponent of the whole numbers that come outside the square root, and then the remainders go inside. So altogether that looks like 5a squared times the square root of a. Okay, now number 12, I'm going to break it up. So I'm going to have the square root of 45 over here, and then I'll do the square root of a squared over there. Okay, well, there's a little 2 there, so 2 divided by 2 is 1, so that just simplifies to a. Now, if I go back to 45, 45 is not one of the ones off my sheet, so I want to find something that breaks it down evenly, and I know that 9 and 5 go into 45, and 9 is on my list, and the square root of 9 is 3, and then I have the square root of 5. So when I simplify this, I want numbers that go outside. They don't have a square root to go together, so 3a, and then the pieces underneath the square root separately, so the square root of 5. Okay, so the number 13 looks a little bit different. So instead of having 1 and breaking into 2, we have 2, which means we could put it together by multiplying 3 times 3, which is 9. And the square root of 9 is 3. So using that property can go in 2 directions. You can break it into 2, or you can take 2 and put it into 1, whichever one kind of helps you simplify the easiest. So 14, I can take those 7s, like I did in number 13, and put them together as the square root of 49. But the numbers that were outside also get multiplied, so our coefficients of 3 and 5 get multiplied into 15. So now I have 15 times the square root of 49, which is 7. So if I multiply those together, I get 105. Number 15, when I'm dividing, just like multiplication, I can just divide what's underneath the square root. So I can look at my coefficients here. 32 divided by 2 is 16. So I'm going to have the square root of 16. Now the values in here are just like what we've been working on with our properties. So when I'm dividing, I subtract. So 1 minus 3 is 2, or negative 2, so it needs to go on the bottom as the square root of a squared. Okay, so the square root stays, you just divide what's underneath there. But now I can simplify what's underneath the square root because the square root of 16 is 4, and the square root of a squared is a. So my simplified answer would be 4 divided by a. 16, 17, and 18 are going to get challenging, so we'll just do them piece by piece. So 16, again, I have the number, my square root of 50, and then I'm going to break up the square root of c squared and the square root of d to the third into their own. So 50, I'm looking for one of those numbers from that list that break it up evenly, and 25 goes into 50 2 times. Now 25 is one of those numbers, so the square root of 25 is 5, and then I still have the square root of 2. So here again, there's a little 2 sitting outside, so 2 divided by 2 is 1, so those all come out as just c to the first, or just c. And we're going to multiply all of our answers here. Then I've got 2 here, so 3 goes into 2 one time with a remainder of 1 that stays on the inside. So I have times d and the square root of d to the first. So what I'm looking for is all of the numbers that do not have a square root sign to go together on the outside. So 5cd, and the numbers underneath to go together as 2d for my final answer. Okay. So a lot of steps there, just take it piece by piece and then multiply all of your answers together. So in 17, I'll break up the square root of 24 into one of them. I will break up the square root of x to the third. I will break up the square root of y. And this one I also get another one for the square root of z to the fifth. So 24, I'm looking for a number off of that list that breaks up 24 evenly. So that would give me the square root of 4 and the square root of 6. 4 is on my list and the square root of 4 is 2. And then I'm left with the square root of 6. If I'm looking at my x's now, again, there's a 2. So how many times does 2 go into 3? That's once, with a remainder of 1 inside as well. And I'll bring that down here. Again, there's a 2 sitting outside these, so nothing comes out there. So I'm left with just the square root of y, because there are not any, 1 doesn't go into 2 evenly. And then z to the fifth means I can take 2 groups of 2 out, leaving me with 1 inside. So I've got z squared and the square root of z left. So I've got a lot going on here. So what I'm going to do is take everything outside that does not have a square root symbol and put them together. So 2x z squared, and everything left on the inside, 6x y and z. So 6x y and z also go together on the inside. Okay, I like to circle or underline so that you can see that you've remembered to put everything into your answer, because there's a lot of information going on there. Okay, and then 18, I think I'm going to get some more space here and bring 18 down here since I'm running out of space. So again, I'll break up the number. I've got the square root of 60, and then I've got the square root of r to the third, the square root of s squared, and the square root of t to the fourth. So I want to break up 60 with a number off that list, and the square root of 4 and 15. So 4 times 15 is 60, and 4 is one of the numbers off that list. So that gives me 2 times the square root of 15. Now a square out here means one group of r's can come out, and then 1 is left inside. So one group of 2 with a remainder of 1. Again, I'm looking for how many times 2 goes into 2, and that is 1 whole time. And then how many times does 2 go into an exponent of 4? And that's 2 times with no remainders. So to put all of my outside values without a square root together, that gives me 2rs t squared. And then what's left inside the square root is the square root of 15r. Okay, so lots of pieces of information. Just keep referencing that original list and break it down piece by piece.